match the given graph with its equation. So this is an ellipse. All of them have plus signs in the middle on our answer choices. So we need to figure out where the middle point of this is. It looks to me like the middle point is right here at -1, 3. We also need to look at how far the graph goes left and right, and up and down. Left and right, it looks like that's 4. Up and down, it looks like is 2. And so we can put all that together into a standard form. If we were writing it out, we'd write x plus 1 squared over 4 squared, which is 16, and then y minus 3 squared over 2 squared, which is 4, equals 1. So that answer choice is B. That matches up with that. Sketch or graph the hyperbola. So this isn't in standard form. That's the first thing that we want to do, is divide all of these by 900 so that we can get a 1 on the right side, which means that it'll be in standard form. So that would give us y squared over, I think that's going to be 25 minus x squared over 36 equals 1. So that means this is a hyperbola that's centered in the middle at 0, 0. And it means it goes up and down 5, because that's what's under y, left and right 6, since that's what's underneath x. So remember, with hyperbolas, we draw a box. And then we draw our asymptotes. And because this is y squared first, we draw our curves on the top and the bottom of the box. If x squared is first, we draw them on the left and the right side of the box. This says solve for y and use a function grapher to graph the conic. And actually, you could probably graph this without actually solving for y. I'm putting it in standard form because this is an ellipse, but the answer choices, whenever this becomes multiple choice, are going to have what y equals in the answer choice, and that to me was an easier way to look at which answer choice was right. So I would recommend you go ahead and try to solve for y, since it's about the same amount of work anyway. To do that, we get all of the y's on one side and everything else on the other. If we were doing standard form, we'd leave the x's on the left side and we'd complete the square twice. But if we're just solving for y, we only need the y's over on the left side. Remember that when you're moving things, that you have to change their sign. So this is -16x squared minus 32x plus 12. Now we're ready to complete the square on the y's. So I would divide this 4 by 2 and then square it. That's how I get this number. I add it to both sides, and then I factor this side. This will be y plus 2 squared equals -16x squared minus 32x. 12 plus 4 is 16. We're going to square root both sides. And so remember that when you square root something in an equation like this, that means there's a plus or minus sign in front of that square root now. Also, I would like to factor a 16 out. If all we were doing is putting this into the calculator and matching up the graph, then we wouldn't necessarily care about trying to simplify underneath that square root. But since we're looking for a particular multiple choice answer, they did some simplifying, so that's why I'm doing this. If I take the 16 out, this is what I get. And then basically what we're going to do is say, oh, I can take out that 16 by taking the square root of it, so that we'll end up with a 4 on the outside of our square root. We can also subtract the 2 over to this side. So that gives us y equals -2 plus or minus, pull out the 16 and it becomes 4. And then inside of our square root we have -x squared minus 2x plus 1. You can put that into your calculator and graph it. You get an ellipse that's like over here or something. But I would look for the answer choice that has the right y equals, and then secondarily look at the graph personally. We had formulas for finding a point in a translated system, where we said that x prime equals x minus h, and we said y prime equals y minus k. That might already be on your graphic organizer. So, I mean, this is our x and our y, this is our h, this is our k. We just plug it all in. X prime equals 3 minus the square root of 7. Y prime equals -3 minus 5. We can't do anything to 3 minus the square root of 7, but -3 minus 5 is -8. So there's our new point. Alright, rotate the coordinate axes to eliminate the xy term. So I have listed out on here kind of the formulas that we're going to need for this, and we also need to know that we have an A term, a B term, a C term, D term, and an E term, but not an F term. So this is going to be a little bit different than the ones that we've generally done in the past, but I think we're up to the challenge. I wouldn't worry about it too much. All right, first we need to find the angle alpha to rotate this. So cotangent of 2 alpha equals A, which is 1, minus C, which is 1, over B, which is 2. So we're really doing cotangent 2 alpha equals 0. So here's how I like to figure this out, is where is cotangent, regular cotangent, going to equal 0? It's going to happen up here where we have 0, 1, because it's our x term over our y term. That's 90 degrees. That's what 2 alpha is, because cotangent of 2 alpha is 0. So if we're looking just for alpha, we divide that by 2 and we get 45 degrees. Now inside of these formulas we need to know what cosine of alpha and sine of alpha are. So cosine of 45, we'll get your unit circle, square root of 2 over 2. Sine of 45, square root of 2 over 2. So let's fill into these formulas to get our new coefficients. A prime equals, A is 1, and we have square root of 2 over 2 squared. B is 2, and square root of 2 over 2 times square root of 2 over 2. And then C, and square root of 2 over 2 squared. If we work out that, the first thing ends up being 2 over 4, then 4 over 4, and then 2 over 4, and then we add those together and we get 2. B prime, I don't have written there, B prime is 0 because that was the reason that we picked that alpha was 45. C prime, we need C times cosine squared minus B cosine sine, and then plus A sine squared. If we work that out, you get 2 over 4 minus 4 over 4 plus 2 over 4, which gives you 0. And then D prime, D is 4 square roots of 2. Cosine is the square root of 2 over 2. E is negative 4 square roots of 2. Sine alpha is square root of 2 over 2. Those are going to cancel each other out, and we're going to get 0. E prime equals E, which is negative 4 square roots of 2, times cosine, which is square root of 2 over 2, minus D, which was positive 4 square roots of 2, times sine, which is square root of 2 over 2. So this gives us negative 8. Hang on. Yeah, negative 8. Because the square root of 2 times square root of 2 over 2 is going to go away, basically. So we just have negative 4 minus 4, which is negative 8. So now we know all our coefficients. We just need to plug them in with our primes. So a prime was 2, that goes in front of x prime squared. And then we don't have a b prime, a c prime, or a d prime. The next thing we have is e prime. The e prime goes in front of y prime. So negative 8 y prime equals 0. Let's say that might not be an answer choice. Maybe the answer choice they have, for whatever reason, they solved for y prime. And so to do that, you would add 8y prime over to the other side and divide by 8. So y prime equals x prime squared over 4. I think that's what the answer choice is going to look like on the test, but just be prepared to have to kind of move stuff around like that. 32. Find the polar equation of the conic with focus at the pole, having the given properties, and identify the conic. Well, we have, hopefully in our graphic organizer on this section, some helpful information. For one thing, if the directrix is at x equals negative 8, since it's at x equals a negative number, then we know that we're looking at this standard form. Okay, which makes this really easy, because if our directrix is negative 8, that means that k is 8. If the eccentricity is 4, that means we know what e is. And since it's 4, we should have written down somewhere that if e is greater than 1, then that means this is a hyperbola. And then we just need to plug these things in to our formula. R equals 8 times 4 over 1 minus 4 cosine theta. So it's really 32 over 1 minus 4 cosine theta. Determine the eccentricity, the type of conic, and the directrix. Very first thing we have to do is get this into the form that tells us all of those things. That form has a 1 right here where the 2 is, so we're going to divide everything in this fraction by 2 on the top and the bottom. So that is going to make this 9 halves over 1 plus 7 halves sine theta. So now we know that this is E, and we know the top is KE. So we found the eccentricity, 7 halves. The type of conic, since this is a number greater than 1, is a hyperbola. Now all we need is the directrix. So since this was a positive and a sine graph, it's going to be y equals some positive value. And we know that KE equals the top, which is 9 halves. We know now that E is 7 halves. So we just need to solve this. K equals 9/7, which means that our directrix is 9/7. Y equals 9/7, I mean. how many 12-letter strings can be formed with the letters D, E, F, and G if each letter can be used more than once. So think of it like almost like you're drawing letters out of a hat. You've got 12 spots to fill, so that first spot, there's 4 choices. The second spot, since we can reuse letters, there's still 4. Third spot, 4. And then it just keeps going until you have 12 spots. So this means we're doing 4 to the 12th, which is a really big number, 16,777,216.